How to graph y equals the cosine of x using the unit circle dance and with proper vocabulary. This is part of the Family of Functions series. You will need paper and a straight edge, or you can download this PDF and print it. Press pause as needed anytime during this video. Graph y equals the cosine of x. Before we begin, we need to recall the unit circle values, and here they are. Recall that the cosine is the first coordinate of each point here. We also need to recall in what quadrants the cosine is a positive number and in what quadrants the cosine is a negative number. Press pause, resume when you're ready. Cosine is a positive number in quadrants 1 and 4, and we'll highlight those right here, all positive values for that first coordinate. The quadrants is a negative number in quadrants 2 and 3, and we'll highlight those. You can see those are negative all in the second and third quadrant. To help you remember the unit circle values, we're going to separate these values into what I call families. The first one is the axes families, the values that are along the axes, x and y axis. So these are the 5 that you should just know. Press pause, resume when you're ready. So the cosine of 0 is 1, because 0 lands right here, and 1 is the first coordinate of that point. Cosine of pi over 2 is 0, first coordinate is 0, and so on. The cosine of pi is negative 1. Cosine of 3 pi over 2 is 0, and the cosine of 2 pi is back to 1. Press pause, resume when you're ready. The pi over 6 family, these are the 5 values. Press pause, resume when you're ready. Cosine of pi over 6 is radical 3 over 2. Pi over 6 lands here in the first quadrant. It's positive radical 3 over 2 is the first coordinate. Cosine of 5 pi over 6 is negative in the second quadrant, negative radical 3 over 2. In the third quadrant, negative radical 3 over 2. And the cosine of 11 pi over 6 in the fourth is positive radical 3 over 2. Press pause, resume when you're ready. The pi over 4 family, these are the 4 values you should just know. Press pause, resume when you're ready. The cosine of pi over 4 is positive radical 2 over 2, the first coordinate of that point. Cosine of 3 pi over 4 in the second quadrant is negative radical 2 over 2. Third quadrant, negative radical 2 over 2. And the fourth quadrant, positive radical 2 over 2. Press pause, resume when you're ready. Pi over 3 family, these are the 4 values you should know. Press pause to figure them out. Resume when you're ready. Cosine of pi over 3 is positive 1/2 in the first. Cosine of 2 pi over 3 in the second quadrant is negative 1/2. Cosine of 4 pi over 3 in the third quadrant is negative 1/2. And the cosine of 5 pi over 3 in the fourth quadrant is positive 1/2. Press pause, resume when you're ready. A quick summary of those families. Cosine of the axes values you can see are either negative 1, 0, or positive 1. The cosine of pi over 6 values is either positive or negative radical 3 over 2. The cosine of pi over 4 values are either positive or negative radical 2 over 2. And the cosine of the pi over 3 values are either positive or negative 1/2, depending upon the quadrant. Press pause, resume when you're ready. To graph y equals the cosine of x, we need to do 2 things before we begin. The x-axis must be calibrated in fractional parts of pi, And the y values need to be approximated with decimals, like radical 2 over 2 and radical 3 over 2. So these are the fractional parts of pi that we need to put on the x-axis, because those are the values we know the sine and cosine of. What is the least common denominator for these values? Press pause, resume when you're ready. 12 is the least common denominator for those denominators there. So when we create our axes, we're going to calibrate the x-axis to show each pi over 12. For example, you'll notice here 1 12, 2 12, 3 12, 4 12, 5 12, 6 12 reduces, or simplifies, I should say, to pi over 2. So pi over 12, each one of those is marked off pi over 12. You can either download and print the PDF with the trig axes that we created, or you can create your own trig axes with a centimeter ruler. We suggest letting each half of a centimeter represent pi over 12, and that means that 3 centimeters would be 6 pi over 12, or pi over 2, and 12 centimeters distance would be 2 pi. On the y-axis, we're going to let one unit be represented with 2 centimeters. Now the reason for that is that pi over 3 is approximately a 1, and pi over 3 is about 4 pi over 12. So 4 times that half centimeter would be about 2 centimeters. So when we did that, so that the axes would be square, proportional. So go ahead and draw your axes, or print and use the PDF so that you can draw the graph of y equals a cosine of x. Press pause, resume when you're ready. The y values also need to be calibrated, or I should say approximated, with decimals. So go ahead and use the calculator right now to rewrite each of the following, rounded to the nearest thousandth or to 3 decimal places. Press pause, resume when you're ready with those answers. So radical 3 over 2 approximates to about 0.866, and the square root of 2 over 2 is about 0.707 to 3 decimal places. Make note of these two values as we will use them often. Press pause, resume when you're ready. So go ahead and draw your axes, or print and use the PDF to draw the graph of y equals a cosine of x. Since this is your first time probably, we want to make sure you recall the decimal approximations to these two irrational numbers. And we're going to create a table for each quadrant and then plot the ordered pairs. So here are the values for quadrant 1, including the beginning and end of the axes of that quadrant. Complete this table, copy and complete this table for quadrant 1. Press pause, resume when you're ready. So these are the values that you should just know, and these are the decimal approximations to help us plot these ordered pairs. So go ahead and plot the points right now. Press pause, resume when you're ready. So 0, 1, we're going to show it where it is on the unit circle. So 0 lands here, and the value for the cosine is 1, so 0, 1. The cosine of pi over 6 is about 0.9, so to speak, pretty close to 1. Cosine of pi over 4 is about 0.7. Pi over 4 is in the middle of the first quadrant. Cosine of pi over 3 is a half. And the cosine of pi over 2 is 0. Go ahead and copy and complete the table for quadrant 2. Press pause, resume when you're ready. So these are the values that you should just know, including the decimal approximations. Notice these are all negative in the second quadrant here. Plot the points, press pause, resume when you're ready. So 2 pi over 3 lands right here in the second quadrant. The first coordinate at that point is negative a half. 3 pi over 4, comma, negative 0.7. 5 pi over 6, comma, negative 0.9. And at pi is exactly negative 1. Copy and complete the table for quadrant 3 and press pause. Resume when you're ready. And these are the values that you should get. Plot the points, press pause, resume when you're ready. Seven pi over 6 here is in the third quadrant. So over 7 pi over 6, down about negative 0.9. 5 pi over 4, negative radical 2 over 2, which is about negative 0.7. 4 pi over 3, negative 1/2. And at 3 pi over 2, it's exactly 0. Fourth quadrant. Copy and complete the table for quadrant 4. Press pause, resume when you're ready. These are the values, all positive in the fourth quadrant for the cosine. Plot the points, press pause, resume when you're ready. Five pi over 3 right here in the fourth quadrant, over 5 pi over 3, up a half. 7 pi over 4 right in the middle of the fourth quadrant, over 7 pi over 4 and up about 0.7. 11 pi over 6 up about 0.9. And at 2 pi exactly 1. So go ahead and connect the points as follows. Go ahead and follow along with me. In the first quadrant, we'll do it like half of a frown. In the second and third, we'll make a full smile to connect them, make it look like a smile. And in the fourth quadrant, the other half of that frown. Pause is needed. Resume when you're ready. We're going to go ahead and discuss some terminology that you should know. The shape of the curve is called a wave. Pause is needed. Resume when you're ready. The curve is a series of frowns and smiles. Pause is needed. Resume when you're ready. We say that these curves are concave down. The frowns are concave down. Those are more mathematical terminology, concave down. And the smile part, the curve is concave up. Concave up. Pause is needed. Now here's the key thing. The point where the curve changes concavity, that is, changes from concave down to concave up, from a frown to a smile, right there, that key point right there. Or if we change from concave up to concave down, that point right there, those points are called points of inflection or inflection points. So this is an inflection point, or it could be called a point of inflection. Very key there, very key. The top point on a frown is called a maximum point. And in this wave, we have actually two maximum points at 0, 1, and also 2 pi 1. The bottom point on a smile is called a minimum point. That occurs at pi negative 1. Pause is needed. Resume when you're ready. So there are 5 what we call points of interest or key points on a cosine wave. Again, the 2 max points, the 1 minimum point, and the 2 points of inflection. Since the cosine curve or wave repeats, we say that the graph is periodic. And the period of the wave is 2 pi. That is, distance from this maximum to this maximum before it starts the same curve again is 2 pi. That's the period of the wave. Press pause as needed. This is the conclusion of the video.